All right, so let's now get into the formation of these ionic ceramic structures. All right, so like I said, we start with an anion arrangement of a close packed, so in this case FCC, and then we fill the interstitial sites. So this diagram here shows you FCC, so cubic, and it's close packed. So these gray spheres are the anions, and then these symbols that kind of have 4 legs on them are representative of all the tetrahedral sites. So you'll see that there's actually 8 in this structure. It's there's one back here that's hard to see. And then the other ones that have a circle and then 6 little legs on them are the octahedral, and you can kind of see all of those locations throughout, right? So we're gonna basically, this is just a schematic showing you these are the anion positions, and then we're gonna try to fill some version of the octahedrals or tetrahedral locations in this. And so the reason I bring this up is because a majority of the structures that we're going to look at can be built this way. Take either FCC, like we see here, or HCP, and we fill some combination of these interstitial sites. So either they're all filled or some portion of them is filled, and that will give us a majority of the structures. So to do this, let's look at rock salt. So NaCl. We've talked about this in bonding and so forth. So let's look at the structure it forms. And we can do it by taking the FCC arrangement that we have here. And for rock salt, what we do is, okay, so let's start with the anions. So the anions take up all those positions. The anion in this case is chloride. So we fill in those spots. So that's the FCC arrangement. And then what we do is we take the cation, so sodium ion in this case, and we fill all of the octahedral sites. So if I just fill in where all of those are. So if I do that, this gives me the sodium chloride or rock salt structure. So that's why we kind of learn the schematic, because it allows us to kind of think of these structures as anion, close packed, plus cations in the interstitial sites. So this gives us rock salt. So let me show you kind of the power of this sequence where we're packing the anions first. And so this shows you a large number of the binary compounds, so 2 components. Rock salt we just talked about. You can see that here. And then it also shows a lot of the other common binary compounds and how the anion packing is described, the coordination numbers of the metal and non-metal, the site occupied by the cations, so how we fill the sites, and then examples of these various structures. So rock salt alone, they call it the cubic close packed, but it's FCC. If we look at the coordination numbers, we'll see that both of them are coordinated by the other by 6, and then we have a 1-to-1, so MX. So we have 1 metal, 1 non-metal in that structure, and we got that by filling all of the octahedral sites with cations. So examples of that, so we think of this as the rock salt structure. So it can have the compound NaCl, but it can also have potassium chloride. It can also have lithium fluoride, potassium bromide, and then all of these metal oxides that we see. So magnesium oxide, calcium oxide, strontium, barium, cadmium, vanadium, manganese, iron, cobalt, and nickel, right? So all of these form into this type of structure. So if we know how to describe this structure, we can know the structure for all these different materials just with different cations and anions. And we'll get into these others as well and how we describe those from this type of schematic. But first, let's go to a kind of a brainstorming question that's on your quiz. So now that we've kind of talked about the basics of ionic structures, in particular rock salt, brainstorm some factors amongst yourself about what influences the crystal structure of an ionic ceramic. So I told you what the ionic ceramics structure looks like, but what factors actually influence that structure? So stuff we've talked about before. What do you think influences that? So pause the video, brainstorm some stuff, write that in the quiz, and then come back and we will discuss some of those factors.